Dear colleagues, I want to introduce a study on the dependence of the EEG complexity on kinds of the multiple object tracking task. When we speak about systemic processes in the brain, we need to obtain some their characteristics. One of them is complexity. We can evaluate the brain systemic process complexity, judging some EEG complexity characteristics. For example, one can evaluate the correlation dimension of the reconstructed attractor. Other complexity measures we used are fractal dimension, we used Higuchi algorithm, and Lempel-Ziv complexity. Some words about multiple objects tracking task. We have a field, as you see, with several objects on it. In our experiment, we used a black square field and small circles. In the beginning of the task, some objects make several blinks by red. These objects are called targets. Then they become of the same color as others, and all objects start to move. Then they stop, and subject have to point targets. If there are too many objects and targets, not all targets are pointed correctly. There are many other factors that affect the performance, like movement, speed, object's dimension, color, and many others. Here you can see whole multiple objects tracking task procedure. Now subject have to point targets. Now, some words about experiment conditions. In our experiment, subjects fulfilled multiple object tracking tasks of various complexity, and during task fulfillment, EEG was recorded. On the slide, one can see the experiment conditions. I will say sample size is 35 subjects of 18 to 35 years old. They reported no visual impairment. Also, they reported that they have no neurological impairment, and they have no other illness in the moment of experiment. And some words about the mode tasks. We used 9 gradations of complexity, different in the number of objects, targets, and speed of movement of objects. After the experiment, we evaluated subjects' performance and choose 3 tasks which were mostly significantly differing from each other in complexity. Here are the features of these tasks. The experiment procedure was quite simple. Subjects fulfilled more tasks of various complexity. Each subject fulfilled tasks presented in random order. While task fulfillment, we have recorded EEG. from 19 leads in band 1 to 30 Hertz. Also, there was some EEG preprocessing. We cleaned from artifacts, and then we calculated values that characterize the brain process complexity. Then it was a statistical processing. We made pairwise comparison of the obtained sample mean values. We used the post hoc criteria in repeated measures ANOVA design. We used LSD Fisher post hoc criteria. And that here are results. For correlation dimension, we see that when we compare simple and task of average complexity, correlation dimension is mostly increasing. Also, when we compare simple task and complex task, most complex task, correlation dimension increases too. When we go from average complexity task to complex task, there are no pronounced changes. In one lead, slightly less, slightly decrease, and another lead, slightly increase. But this and this two pairs are very, very pronounced. Almost the same thing we see when we calculate the Higuchi correlation dimension. Again, when we compare average complexity task and complex task, EEG complexity in some leads decrease, but it is not as pronounced as change when we compare simple task and complex task. And when we deal with Lamp-Lizif complexity, again, we see the same regularity. When we move from more simple to more complex task, EEG complexity also increases. The only exclusion is one lead, which here when we move from simple task to task of average complexity, this is not too much significant change, just 5% spill level. But in general, regularity is the same. The more complex the task, the more complex is EEG. Thus, we can make conclusion that brain process complexity is well correlated with cognitive complexity, with cognitive process complexity. We think that complexity concept may be considered as a kind of universalia for psychological and mental processes. Thank you for your attention.